Welcome to our tutorial on implementing pathfinding in 3D. In this video, we're going to explore how to navigate through a 3D space intelligently. Pathfinding is essential in game development and robotics, and we're going to make use of the A** pathfinding algorithm to accomplish this. Before we dive into the coding part, let's understand what pathfinding is. Pathfinding is the process of finding a path from a starting point to a target point while avoiding obstacles. In this tutorial, we'll work in a 3D space, so we need to consider not only the length of the path, but also how it interacts with three-dimensional objects. The A** algorithm is widely used for pathfinding because of its efficiency and accuracy. It uses a heuristic to optimize the pathfinding process. We will discuss the main components of the A** algorithm, then implement it in Java. Let's start with the basic building blocks of our pathfinding algorithm. First, we need to define a representation for our 3D world. A common approach is to use a grid where each cell can be occupied or free. For this tutorial, we will represent our 3D space as a simple 10 by 10 by 10 grid. Let's start by creating a class that will represent a 3D point in our grid. Now, let's build our grid class. This class will manage the 3D grid and represent obstacles within that grid. We'll also include methods to check if a cell is walkable and to mark cells as occupied. Next, we need to represent our nodes. A node will keep track of its position in the grid, whether it's walkable, the cost from the start node, the cost to the target node, and its parent node to reconstruct the path later. Let's create a node class. With our node class in place, let's move on to the next step, implementing the A** algorithm itself. At its core, A** works by exploring nodes and using a priority queue to determine the next node to evaluate based on the lowest cost. We will now create our main pathfinding class and implement the A** algorithm logic within it. The core of our algorithm is now complete. But before we run our pathfinding method, we need to add logic to find the neighbors of a given node. In a 3D grid, each node can connect to 6 neighbors: up, down, left, right, forward, backward. Let's implement this in our getNeighbors method. Now that we have our neighbor retrieval method, let's put it all together in our main method. We will initialize our grid, mark some obstacles, and call the A** algorithm to find a path from a start point to a target point. Great! We have implemented our 3D pathfinding using the A** algorithm. Now, let's run our code and see how the pathfinding algorithm behaves with our obstacle layout. As we can see from the output, our algorithm effectively navigated from the start point to the target point while avoiding the obstacles. This is a basic introduction to 3D pathfinding using the A** algorithm, and you can build on this foundation to implement more complex navigation systems, consider diagonal movements, and adapt to dynamic environments. In conclusion, the A** algorithm is a powerful tool for pathfinding in 3D space, and by understanding its components and following through our step-by-step implementation, you can start creating intelligent navigation systems in your applications. If you enjoyed this tutorial or found it helpful, please leave a like, subscribe, and share your thoughts in the comments below. Until next time, happy coding!